everyone, welcome back to Explore Electronics. Today let's begin with module 3 and let's learn about arrays. Now what is an array? We all know what is a variable. So a variable is nothing but the name that we give to a memory location where we can store some data. Array is also a variable that stores multiple data of same data type. So the difference between a variable and an array is that the array can store multiple data of same data type. We can also say that array is a collection of homogeneous elements of same data type. So when I say homogeneous elements, which means the data should be of same kind. And they also called array as subscripted variable because when we have to access the data which is inside the array, we need indexes or subscripts. That means if we have an array and it has some data in it, if we want to access one particular data from that array, we need to access it through the index number of that data. So now the data in the array will be stored in contiguous memory locations. That means suppose this is the memory. It is some memory location. Suppose the address starts here and so on. Now you might be wondering why I have written 1000 and 1004, 1008. So let's take an example which I have written here. Here I have defined an array. So this is the data type, this is the name of the array, and this is the size of the array. This array called marks can have only integer values in it. And how many integer values it can hold is 50 numbers, 50 integer values. So suppose if we are giving the values to this array. Now we all know that the size of integer is 4 bytes. So the first element in this array, which is marks of 0. So when I write this, the 0 means the 0th index. So this is first index, this is second index. So the index of the array begins with 0 and goes on till the size that we have mentioned. So the 0th element, if we want to access, we need to mention the array name, and inside the bracket, square bracket, we need to mention the index number. So if we want to store the first index data, so it is 1. So we will be getting it in the index 0. Suppose the index 0 is pointing to this address. So what will be stored here is 1. Now, since this 1 is an integer, it is going to be stored in 4 bytes of space. So where will the next data be stored? Obviously, it will be stored after 4 bytes. That is why I have written here 1004. That means the data of the second index will be stored after 4 bytes. So here we are having our second data, and again after 4 bytes we will have our third data. So this is how the data in the array will be stored in the memory. And if you observe here, the data will be stored in contiguous memory. That means one is stored in this address, and the immediate next address, the second number will be stored. That means it is not like it is storing 1 here and 2 here and then somewhere it is storing the next data item. No, it is always the contiguous memory allocation for an array. So the data stored in an array will be continuously arranged. Now, we all know what are primitive data types and derived data types. So here you have to note that array is a derived data type in C programming. And this derived data type array can hold the data of different primitive types. That means it can have the data which can be of type integer or character or double or float or any other primitive data type. So this array is a derived data type. So this is all about array. Now we'll see what is the need of this array. Why do we need arrays in the program? Let's understand this by taking a scenario. So let's say that we need to store marks of 100 students for PSP subject. Now how do we do that generally? Just forget about the concept of array. And how do we do it if we want to store 100 students marks? We need to define one variable called student1 and assign the subject marks. For example, say 45. Now the student 2 has scored 50. Now student 3 has scored 38. Likewise, we need to have 100 different variables to store the data of 100 students marks. So this is practically very wrong to do it this way. Even if you declare 100 different variables, the program still executes. But it is practically not correct to do this way. So the solution to this kind of problems is array. You can just have one single variable and say that this variable is going to have 100 values in it. So we have declared the variable called students marks. So this is our array and it is of type integer. So we'll just have to put in 100 different data inside it. So what we have written, this is our array, and how the data will be here. Suppose student 1 scored 45, student 2 has scored 50, student 3 has scored 38, student 4 has scored 45, and so on till student 100. The values will be stored like this. Now if you need to access the marks of first student, what you have to do is just take this array and specify the index number. We all know that the array starts with 0th index. So this is the 0th index. And this one is first and second and so on till 99th. So if we want to access the value or access the marks of student 1, we need to say that index value is 0. Suppose we need to print the marks of the first student. What we can do is just say that take the marks from 0th index and print it. So the simplest way of handling more data using one variable. So this is why arrays are needed in programming. Now let's understand what are the different types of array. We have one-dimensional array, two-dimensional array and multi-dimensional array. For now, let's begin and understand what is one-dimensional array. So as you can see here, a list of items can be given one variable name using only one subscript. That means it has only one index in it. So this is why it is called one-dimensional array. Here if you observe, this data, we only have it in one dimension. That means we only have columns data. Say this is a matrix. What we call this matrix is a two-dimensional matrix. It has rows and columns in it. Likewise, the array which is having only columns is called one-dimensional array. There is no rows. Suppose if you want to write two-dimensional array, it will be like this. Int marks, say we have 2 rows and the data goes on. So this is how the two-dimensional array would look. I will explain what is two-dimensional array in detail coming videos. For now, just learn about one-dimensional array. This is how we need to declare the array, and this is called initialization of array. Initialization means we are initializing this array with values. And we have two types of initialization. One is compile time initialization and one is runtime initialization. So what is compile time initialization? That means we are assigning the values during the declaration itself, like this. So we are just declaring this array and assigning the values there itself. This is called compile time initialization. Now what is runtime initialization? This is assigning the values when the program is executing. For example, if we are taking the data from the user and then filling the array with the user entered data, at that time we call it as runtime initialization. Before understanding this with an example, let's see what are different types of compile time initialization. So we have initialization with size, without size, partial initialization and initializing all values with 0. So these are different ways how we can initialize during compile time. So initialization with size means we are specifying the size of this array. Suppose here you can see we have specified that this array will hold only 4 integer values. So this is initialization with size. Now what is without size is the same array. If I say just blank here and then I am just initializing the values as it is. So here what happens, the compiler will see how many data that we have initialized into this array. So it will see that it is an integer and it will see how many data we have. So in this case we have 4 data and it's of type integer. So the compiler knows that integer should be given 4 bytes of space. So what it does, it will calculate how much space it needs to allocate to this array. It will allocate 4 into 4. That means 16 bytes of data. It will automatically allocate by looking at the initialization. This is one more way to do it. Now we can also initialize the array partially. That means suppose we have this array and we have mentioned the size as 100. Now we just know only 5 values. Suppose we only know these 5 values for now. So what the compiler does, as soon as it sees the size of the array, it will allocate the space required to store 100 integer numbers. But what we have initialized is only 5 numbers. So the rest of the memory locations, the compiler is going to treat it as 0. So the values there will be 0. Automatically it is going to append this value. Now initializing all values with 0. Now we can also initialize the array to 0. That means initially we don't want the array to have any data, but just that it will hold zeros. So what we can do, suppose we mention the size as 100 and just one zero inside this. So this means all the 100 memory locations will be having 0 in it. So this is what we call as initializing all values with 0. Now coming to runtime initialization. So there is a small example here which says we have an array of marks and size we have mentioned as 5. Now we are asking the user to enter the marks. So we are printing it with printf statement, and now we need to read the data one by one and put it into this array. So suppose this array is marks and what it is having 5 different places. So the first time when we enter the loop, we are initializing I to 0 and we want it 5 times. So we want 5 iterations. So we are starting from 0 till 4. So what we are doing, each time we are reading the data and putting it into this array. Now initially in the first round I is 0. So we will be entering, since this condition is satisfied, and we are reading that. So we are reading into marks of I, that means marks of 0. So this is marks of 0, this is marks of 1 and 2, 3 and 4. So the first time when we run this loop, the marks that the user entered, suppose say the user has entered 25. So that marks will be stored in 0th index of this array. Now again I value is incremented and it will go and check the condition here. It is still satisfying. So the first index, that is in the second round, I is incremented to 1. So now the marks of 1, that means this location will be having the second user entered data. Likewise, it will fill all the memory locations like this. So this is how we can initialize the array during runtime. So this takes place when the program is running. That's why it is called runtime initialization. Now how do we access the array? Just now we saw an example to read the array, read into the array. That means we are loading the array. Now how to access the array? That means how to read from the array. So this is an example we have to calculate the total marks. Suppose we have 4 marks and we need to calculate the total. So what we do, just initialize one variable called total and put the value as 0. Now we have one more, we have declared our array. We need to mention int array name as marks, and we are saying it will hold 4 integer values. So we have initialized this array. This is compile time initialization. Now we need to calculate the total and print it. So what we do, using the for loop, we are just incrementing and beginning the I with 0 and incrementing it and calculating the total. So initially the total we have set it as 0. Now in the first iteration I is 0. So the total will be 0 plus marks of 0. Marks of 0 is 0th index what we have. It is 35. So now the total value is having 35 in it. Now in the second round 35 will be added. 35 will be added with marks of 1. 1 means first index. First index is 44. So this is index 0, this is index 1, index 2 and index 3. Likewise, by the end of this loop, the total will be having sum of all these 4 marks. At the end, we are coming out of the loop and we are printing the total value. So this is how we can access the array. What we are doing, just looping through the array and accessing the elements with the help of the index value. So this is the index that we are using to access the array elements. So in the next video, let's understand how to use arrays with functions, and let's see about 2-dimensional arrays and some example programs.